Hey, Alessio.
Hey, Alexander.
Where are you?
Now we are on MediaCar, our experimental vehicle, and now it is starting up. In fact, you can see the NVIDIA Jets on boot up page, and on the top you can see the sensor set installed on the vehicle. In particular, we have two GNSS antennas that provides not only the position but also the orientation of the vehicle. A LiDAR, a Velodyne LiDAR that is used to obtain in combination with the camera here not only the detection of the obstacles but also their distance calculated with the LiDAR.
From here.
Come to Emilio.
Hey, Emilio.
Hi. Here you can see our virtual cockpit, and if I go in front of the vehicle, car is able
To recognize Emilio.
to recognize me. So you can put on the LiDAR point cloud from the cockpit. You can just push the button, Alessio.
Okay, sorry. Okay,
Ah.
this is the LiDAR point cloud
This is
projected
cool.
on the
Connecting on
image.
the image.
Yeah. Please,
Now-
Emilio, could shift to the driving modality.
Because now we are in remote mode, so the vehicle can be driven only by this remote controller. For example, if I shift this axis on this side, you can see the wheel.
Can you do it again? Mm.
And I can also move the vehicle. For example, if I put here the retro gear, and then if we move outside for
Looks
our
like Pip-Boy in Fallout.
yeah. If you see, if I accelerate, the vehicle starting to move. We can also brake from here. But now if I change the modality and then I switch from remote mode to self-driving mode, now Alessio have the control of the car. And if the professor can take the car outside just for showing you. Alessio, let's switch with the professor. Okay. Yeah, you can go, you can go. And now remember the button that changed the steering mode is shut, I think, for 3 seconds. Or we can change I think it was S1. Okay, now we change the steering mode. So as you can see, the front and the rear wheel turn in the same direction.
Yeah.
So you can just slide. And then we can also change the steering mode for 3 seconds. 1, 2, 3. And in this case, the rear wheels turns in the opposite direction of the front wheels, so you can decrease your turning radius and have better turning driving.
Yeah.
So, and then better maneuvering performance when you park, for example. And yeah, from here we are also able to detect other objects like cars, for example. Yeah, and here there is our drive-by-wire system.
I'm implemented on drive-by-wire system. In this case, it's based on Ferrari steering wheel, but the interface that I provided is for all the joystick that implements the USB class steering wheel. So you can change your steering wheel device in order to pilot the vehicle with a different input device. For example, we have done also some works, some roads, some ride with using a Xbox controller or a PS3 controller, but now we have a high performance gaming controller like the Ferrari's SF1000 steering wheel.
Here, if you move on the front side of the icon, I can show you the GNSS, or better the INS, that is a combination of GNSS and IMU. Here there are the dual antenna that receive the satellite signals, and we have in this case two antennas because by measuring the difference in the phase of the signal, we can also estimate the heating of the vehicle directly from the satellite signals. And also here there is the antenna that receives the correction, the RTK correction from the base station through the internet connection, because this device is equipped with a cellular SIM that have an internet package that is able to subscribe to the near base station depending on the position of the vehicle and receive the RTK correction. And currently, for our campus position, the near one is about 14 kilometers, so we can achieve an accuracy of about 20-40 centimeters for our system. And then we have a LiDAR that is a basic LiDAR with only 16 beam, so it's not the most performant one. But it's what we use for just only object detection. And in this case, the LiDAR is fused with camera, because through the points of this one, we can use this for distance estimation. So the images are the one that are responsible for the object detection, and then the intersection between the point cloud and the bounding box is used for retrieve the LiDAR points and calculate the distance between the vehicle and the object that is detected.
And where's the camera base?
The camera is here. So here we have our single camera. And this is our sensor kit. It's a basic sensor kit, but we are working for improving it and also have a new platform. And yeah, I think that I don't know, let's see if we have other stuff to show. You can also program and coding in live by opening the shell and motor system. It's just like what we saw in Estonia. We have a live dashboard. The rest of the system can be monitored through these, but we also have a keyboard that is connected to the Jetson.
Also using SSH.
What's that? Is that canvas or something?
Where?
Like this colored.
No, it's the
things.
pinout of the NVIDIA Jetson in order to use the appropriate communication interface in order to communicate with the sensor set. It's normal. For example, here there is the ground, here there is the first in and out of the first interface of the first CAN interface that actually is used to pilot the chassis, and that's the second CAN interface that now at the state of the art of these days is used to obtain the GNSS data from the CHC nav in front of the driver.
We also have here an emergency button that can be pushed. Now is just. But for emergency, we can stop the vehicle by pushing it here. And we also have another button here that can be pushed in the same way. So for redundancy, we have two buttons. And another thing that I forget is that all the motors are single motors directly equipped on the wheel. So these are motor wheel. Here there is the motor that drives this single wheel, and so for this case we have 4 different motors that drive each wheel. So braking and motor are just here, and this is our suspension system. But yeah, basically these are electric motors that can reach about 60 kilometers per hour of speed. It's not too much, but it's what is necessary for us for our application. So, and for driving in a safe way and testing our algorithm. And yeah, here there are the ultrasound sensor that I just integrate in the vehicle. I also decide where to put it, so the optimal positioning of them. We have 2 sensors here, 2 sensors here, one here and one here, another 2 sensors here, and then on the same side, on the right side, this. And through only ultrasound sensors, so without using cameras or LiDAR, we can create an occupancy map in 2 dimensions to find the free parking slot in order to execute a parallel or a perpendicular maneuver, totally in a focus. There is the distance estimation.
All right.
And from here, you can see what I told you before. So the intersection between the bounding box and the point cloud gives us the point that are used to estimate the distance between the object and the cloud. So the point that you see in the green box are one that are used. And I think that we use the median of this point for the distance estimation.
Yeah.
I don't know if the professor has something to.
No, I think you have discovered everything.
Yeah, this is.
Okay.
Yeah, this is our experimental car.
Yeah. Thanks for showing.